Hi, welcome to my talk, The Road to Hype, how NoSQL became serverless, or for us here in Europe, how NoSQL became serverless. My name is Lehnardt. I'm a CEO at Neighbourhood.ie. We're a company that does JavaScript programming work for money. You can hire us if you need your JavaScript projects to go better. Please hire us. I'm also a co-organizer of JSConf EU. This is what it looked like when we started in 2009. Up until earlier this year, things escalated slightly. And my one very personal claim to fame for Node.js that last week, 10 years ago, Ryan Dahl presented Node.js at our little conference in Berlin at that time. And because he couldn't get the projector to run with his Linux laptop, he gave the demonstration on my laptop, not this one, but like on my machine. So the inaugural presentation of Node.js to the world was done on my computer, which is like very, very cool in a very not important way. It's an honor to speak here, so thank you for having me. Today, I want you to imagine a time before Node.js. The year is 2008. JavaScript is already one of the most popular languages in the world, but there are no JavaScript developers. There are Java developers that do some JavaScript. There are Python developers that do some JavaScript. There are Ruby developers that do some JavaScript, but there's no JavaScript developers. And there's no notion of being a JavaScript developer. There's no JavaScript community, and there's no conferences like this at all. In this world, and bear with me for a little while, we're building a database. It's Apache CouchDB. And when building a database, there's a lot of questions you have to answer. And one of the first questions you have to answer is, how do you talk to the database? And usually, very fitting with the previous talk, is usually some binary protocol that's written in some obscure C library that you have to compile and find the right version and inject into your language, and then something breaks on build because you did it on Mac, but CI runs on Linux. And then you deploy to BSD, and it all falls apart. It's very annoying. So I can't wait for all that WASM stuff that's coming up, so that all that's going to go away. But specifically, for CouchDB, we didn't want to invent our own protocol because there were already a lot of protocols around. And we wanted to have a little bit of better interoperability. So we settled on HTTP as our protocol because A, it existed, and B, it fits exactly to how CouchDB thinks about data. It's very, very nice. And specifically about HTTP, we started to use REST, which became a buzzword around the time. It usually means pretty URLs in Ruby on Rails applications, but we took it a lot further. And mostly then, but today definitely, HTTP is built into everything. Like, there's nothing you need to compile, nothing you do. You can just start using CouchDB from wherever you want really quick. It's really nice. Having a REST API also means that everything inside CouchDB has a URL that looks like this. Here's a resource that what we call a document. You have get, put, delete operations from that. It's extremely straightforward to understand. Right, so the second question you have to answer once you have a protocol is what data representation do you choose for getting data in and out of your database? And usually this is tightly coupled to your protocol. But with HTTP, there's no such thing. The HTTP body is undefined, basically. You can do whatever you want with it. Traditionally, of course, HTML, but everything else you can do across there as well. So the industry standard at the time was XML. And indeed, the very first version of CouchDB used XML as a data format. At that time, though, we were at a tipping point. We, as an industry, realized we had tried to use XML too much, in too many places. And this is not a criticism of XML per se, because it is a nice tool set that solves this very well-defined set of problems really well. We just started to use it for a lot of things that it wasn't really designed for. And that led to a lot of developer frustration. And at the same time, the idea of JSON came up to be more of a better format for the internet, or for the web. So we quickly switched to JSON and pretend that XML stuff never happened. Yes. One of the nice things about JSON is that it doesn't try to be all the things to all programming languages. Where for XML, well, the first thing they did invent is a way to specify data types. And then any language can then specify how their specific data types are represented in XML, so you can exchange all of them real nicely. The problem is that it adds 2 layers of indirection between your application and your data, that in between there's a lot of XML and a lot of Java to make it work. It's not very convenient. Another thing for JSON on the other side here, the nice thing is that JSON is the subset of all the native data types that most of the programming languages share. And it turns out that's a way more lightweight way of sharing data. And this, it's not a controversial statement today to say that JSON is the superior data interchange format. In 2008, I got laughed out of the room. It's a very, very different world than today. However, back in the day, one of the nice things about JSON here is you can take native objects that you are programming with and just serialize them into JSON. And you have a database that stores JSON, you can just put that object into the database. Whereas traditionally, you usually had a library called the an object relational mapper, or ORM, that would take this really nice looking object that you were working with all day and then split it up into lots of tables and rows in the way that a database really liked, but not in a way that you were actually programming with. So every time you had to persist an object, it has to be exploded into all of these tables, and every time you want to read an object, you have to reassemble that from all these different tables, and it's just a lot of work going back and forth to just store some data when you can also just store the JSON if you could. And at the time, I could be extremely funny on stage at that time. I was saying, well, the lines of code inside CouchDB is fewer lines of code than Active Record, which is the ORM built into Ruby on Rails. And I was very clever at the time as well, and I said, well, if you think that the amount of bugs per lines of code is static, which is where linear, we have research on this, you have less bugs if you don't use an ORM. So just store your data right away. So that sounded really cool at the time, trust me. Today I don't have to convince anyone that that's a good idea. The next question you have to answer when building a database is how to query your data. Normally it's stored by primary key, usually an arbitrary ID or some natural key that you have there, but very quickly you will want to be able to query your data by some other property or sort it by last name or birthday, what have you. And this is usually achieved by having an intermediary language inside your database that describes how to take your original data and make it available in a different sort order, make it otherwise defined. So we had to go and find a language that we can use to describe how JSON is transformed into JSON that is stored in a different direction, sort direction. Well, we already have JSON, so may as well use JavaScript, right? So the JS and JSON is already JavaScript, so why not use this? So at the time, we felt pretty confident putting JavaScript into a database was an extremely normal thing to do, which not a lot of people agreed with. We added a pretty sophisticated, and to my knowledge, still to this day, unique incremental and persistent Mapreduce system that took a bunch of ideas from Google search. But most importantly, it allowed you to store all sorts of data and make sense of it, of the semi-structured data, and make sense of it when querying and running through JavaScript, because you can dynamically access everything in your data. And this is still one of the one of the many use cases that CouchDB is used specifically for today. So we took Mozilla SpiderMonkey and put it right inside CouchDB. It's a very, very fantastic JavaScript runtime. We're very happy with it. All right, quick introduction to Mapreduce. That takes hopefully 20 seconds. It allows you to take all of your weird data that you may be having and running a map process over it or running a map function over it, which helps you give it some order so you can work with it a little better. And then you can run a reduce step through it, which then gives you something useful. This is a very, very simple explanation of how this all works. But one of the nice things that is important for this talk is that it is easy to parallelize that data, these operations. All of these could be running on different machines, different servers. And that's the property that Google used to scale Google search at the time. But one of the things that is required for this to work properly is that the map functions and reduce functions are functionally pure or isomorphic. Which means they have well-defined input and well-defined output mechanisms. You receive a doc property, and there's an emit function that you can use to access everything in the doc, and you can have as many ifs and whiles and whatnots in there to make the data into a shape that you really want. But you can't, for example, access information about another document or another doc here inside this function because you don't know. It may be processed on an entirely different server, and you don't want to do this coordination work. So from a functional programming perspective, these are pure functions. Oh, wait, sorry, wrong button. These are pure functions. So finally, the biggest question you have to answer when you're building a database is why? Why go through all this trouble when there are perfectly fine databases around? And I love all databases equally, except maybe one. but why go through all this trouble of doing it? And the answer for CouchDB is data synchronization. It's a unique feature of CouchDB where you can keep data in ways of how you usually think about using in Git, having it local on your machine, have it local in production, have a clone of it for CI and testing, and move it around globally as you like. So you can have a single CouchDB instance somewhere. You can have multiple instances. You can connect them any way you want. You can write in any parts of the server, so you don't only have read replicas if you want. You can have as many of these as you like, and you can spread them as far apart as you like, across the whole globe, and they can all make sense after the other. You can even build corporate hierarchies, and we have one customer that does the elusive mesh networking with CouchDB as well. All of this is just built into Couch and works out of the box. If that's interesting to you, find me after the talk. I'm happy to talk about this at length, but just not here, because this is just part of the setup. One final thing to learn about CouchDB is that it can store binary data with more or less success like other databases. I think Chris this morning may have had experience about storing binary data in Couch. But one of the nice things here is that the binary data in Couch isn't stored inside of the JSON, which incur a big translation cost, but it's actually stored as binary data. And all the stuff that's in JSON is just metadata, the name, the content type, the size, and then each blob of binary data gets its own URL, because everything in CouchDB has a URL, and the parts that make up the URL are defined from what the data is actually in our JSON record here. So, with all this in place, here's something that people started to do in around 2008 with CouchDB. Have a CouchDB instance in a browser, store an index HTML file as an attachment inside CouchDB, because that had a REST API, had a URL, and a browser knows what to do when it fetches an HTML file over a URL, it just renders the interface. That HTML could then have subsequent resources for CSS and JS to give us just static website serving. But then when you have the JS there, you can use XHR or nowadays Fetch to talk back to the database, and not just to get more attachments, no more binary data, but it can use the actual database API to make queries, get other documents out of there, do like all the dynamic stuff you're used to from doing with databases, without any API server in between. So that's pretty cool already. But we took it one step further, because that isn't enough yet. Sometimes it's good to render stuff on the server side. Maybe for accessibility reasons or for loading speed reasons. And because we already had a JavaScript engine inside Couch and people asked us for this, we put in a system that allowed us to transform the JSON that is in Couch into whatever else by way of a JavaScript function. So say you have a piece of JSON in Couch. This could either be a document or a row in a query result that looked whatever way, and you have a function that does some transformation of that JSON into whatever format you want. That function then gets a URL that you can point a browser at, that when you call the URL, the function gets run and the document gets passed into, which then produces whatever the function produces. But because we were reusing the Mapreduce system, which required those functions to be pure, so run in isolation, no side effects, very functionally pure, and we didn't make any changes to the underlying system, those functions also had to be pure. So you had a system where you could upload basically arbitrary JavaScript that would then get a URL that you can call from like a client or from even from a browser to run whatever you need to do. And then take it one step further. With all these pieces in place now, we could have, well, we had a globally distributed way of pushing applications into our database, which was also our API server. And we could have this run on as many machines as we wanted. We could spin up more machines to have more, or run more instances of our app if we had more demand. And we can have all of them synchronized across the globe. So this is all stuff that, oops, sorry, this is all stuff that used to work in CouchDB that still works in CouchDB that you can try out if you want. I'm saying you should, but it's still there. And in our hubris, we thought that this was going to be the next generation infrastructure for the web, the true Web 3.0. Not only have we a way of like consuming hypermedia really fast through like Nginx and Apache, but also have a way of like building dynamic apps to make production of web properties or hypermedia really, really quickly. And we could make it decentralized, take the power from the big corporations, and all of the things that Chris mentioned this morning could be part of this. So 10 years in, still no decentralized web. There are a bunch of initiatives that are looking at making the same mistake that we've made and not looking at what we've made, so good luck with that. But at CouchDB, it didn't take long to realize that that wasn't going to happen. And it might be worth looking at what that is. One of the reasons is funding. There wasn't much commercial interest in this, even though it sounds pretty cool. Nobody said, well, by giving up control, we're going to make more money. Like that equation never worked anywhere, so that doesn't got a lot of funding. And secondly, we need to look at the developer ergonomics. At the time, the usual workflow for building front-end apps was you had an editor, you make edits, you hit Command Save or Control Save, depending on which system you're on. Then you Command Tab or Windows Tab, I guess, over to your browser, reload, and there's your change. And then this would go on 1,000 times per hour, every day, all day, every day. Like you've all done this. But with building CouchApps, as we called them, there was a process in between. You do the edit, you do the save, then you switch to another process, another terminal, and then there was a step in between that you had to do. All the resources that you were building, like the CSS and the JavaScript, the function that should run on the server, all of this had to be taken and compiled into a shape that CouchDB understood, so all the URLs would match up and that the functions were at the right place so they could get called. And then you could tab over and reload. And people fucking hated it. They hated it. Like, we gave them Web 3.0, a truly decentralized future vision of the web, the one thing that everybody's really wants. And they despised it because of the typical developer ergonomics that they were used to. And they still hate it. They've just come to terms with it for other beneficial reasons. But once you had your compile artifact, like put everything together in a way that the server runtime understood, you can have like a planet-spanning, infinitely scalable system that you can have your users access with the lowest possible latency on any continent you like. We even support offline applications. And it was all pretty fantastic to deploy everywhere. And none of this is the surprise thing. We had all the buzzwords from today we had in 2008, but for a bunch of stupid reasons, that didn't catch on, right? So actually, NPM started as a Couch app. Who knows this? Right? Not a lot of people. So NPM started as a Couch app because one of the people who worked on CouchDB was friends with the guy who invented NPM. So they just sat together, and then Isaac said, "Well, I need an API server first." Like, why not just use the database over here? And then like introduced a bunch of the information here, and that all worked out. So, but the way NPM worked is that it only used the Couch app parts that defined how the server worked, like a bunch of endpoints, security, that kind of stuff, all the things that I haven't shown yet. But because the client of NPM is, of course, the CLI and not a browser, all the cool shit we put in, they never use. So in a cruel twist of fate, the most successful Couch app by far, like by many orders of magnitude, didn't even use any of the cool stuff we put in, and we kind of should have taken that as a sign that that wasn't going to happen. But if you like where NPM's success is going, I'd encourage you to start with CouchDB because we have at least one very big success story. So if this isn't good enough as a recommendation to try to look at it, I don't know what is. So next, around the same time, one fateful Sunday, Chris Wanstrath, or defunct, one of the founders of GitHub, ported a simplified form of C template from C++ to Ruby and called it Mustache and labeled it as logicless templates. And it had some properties that I really liked. You can already picture, well, a templating language would make sense as one of those functions that I could run into Couch. So I looked at doing this and implemented, but of course I needed it in JavaScript. So I started to look at that. I tried to make that going. If there's one thing you need to know about my brain, it is fundamentally incompatible with Ruby syntax and semantics. Like, this is not an indictment of Ruby, it's a fine language, I'm sure. I've just tried enough times that I know that there's some cognitive dissonance there, I just don't get it. Luckily, Mustache was like just over 100 lines of code, easy to read, tiny functions, I could make sense of it. But I couldn't, and it turns out JavaScript and Ruby are surprisingly similar languages to the point where I can't even say I ported it over, I transliterated it. That means I went through it line by line and rewrote the things here. As you can see over here, the function names are the same, some of the symbols are the same, even the regular expression is the same. So the one other thing that's a good fun fact about my brain, it really likes regular expressions. So maybe that explains something. Mustache became so successful that it eventually got used on Twitter.com, which at the time was I was very proud of this. Today, less so. At the same time, a number of pull requests came into the project and said, well, you have a regular expression-based parser. That's really slow, you know. It's like, here's a better one that's faster. It's like, that's great. That's also like 10 times as much source code. So by the time the browser is done downloading your template engine, I'm already done rendering, even though the rendering part is longer than on yours. So thanks, no. And then Jacob Thornton, who worked at Twitter at the time, decided to ditch Mustache and rewrite its own parser and found one that had a good balance of lines of source code and performance that worked for Twitter.com. And then he gave a talk about this at JSConf US, and he justified why he released this as a new open source project called Hogan.js. Because he said, like this is his words, the PR to Mustache would have said, hi, I'm replacing your entire project. And he thought that was going to be a dick move, so he didn't do it. And I was in the audience at the time, and he didn't know. And I found this so sweet, as entirely like, this is not usually how open source goes. People are usually know-it-all, angry people, and being considerate is usually not what people are doing. And I was really touched at the time that I do what any self-respecting white guy does, interrupt the talk and go on stage and give him a hug. It was so sweet. Eventually, somebody came up with a non-regex-based parser that was about the same lines of code, and at that point, Mustache was pulled in the modern world. But at the time, that was one of many requests of things that people wanted to put into Mustache. Like, I wanted all sorts of features. And at that point, it was good to have the tagline. It was logicless templates. So I could say, well, the thing you want is kind of logic-y, so we're not having it. Right? It's very easy to not do work. If you say, well, that doesn't fit our motto, we're not doing it. And then at a nice small community tech conference in Germany, FrostCon, somebody introduces me to Yehuda Katz, at the time known for working on jQuery and Ruby on Rails, and say, hey, this is the person who's mustache.js. You guys should talk. And he just like makes a face. And like, I'm sorry, you're going to hate me next week. And then he went away, and he avoided me all evening. I'm like, that was weird. Like, we've met since, it's fine. But the week after, he released Handlebars. And Handlebars is everything Mustache was, plus all the logic-y bits that could be argued should be in there or should not be in there, and ended up taking the world by storm. Today, I'm using Handlebars. Right? It's that good. That was also around the same time when it was really clear that the idea of CouchApps wasn't going to happen inside CouchDB, and we focused the project back on like data synchronization, scaling, all the things that databases need to do, which was the right call for the project. But the idea of easily deploy, like there's still people who, like to this day, who spend like hundreds of thousands of dollars and euros too of engineering time to build APIs that take some database input and turn it into JSON so a single page app can consume it. I don't get it. Like, I really don't get it. There's databases that do JSON. You can save you all this trouble. So that kind of story didn't let me go. This idea of having a single page app that directly sits on top of a backend that can support the full app without like having an intermediary server there. So we started a new project called Hoodie, which was meant to take this idea, like encapsulate this idea and make it separate from CouchDB so like the projects don't get confused. And our goal was with Hoodie to make we meet developers where they are, have a script source include that look kind of like this. You get a Hoodie object, and then you can do all the things you need in a web app. Everything that every web app needs to do was supposed to be in this API, kind of like with Rails, like user authentication, data storage, like all the stuff available as modules, and then you can focus on building the apps you want. It still works pretty cool, yes, but however, we tried to do too many things at the same time with Hoodie, so it faltered, petered out a little bit. Some of the reasons that Chris mentioned earlier today in his talk about like organizing community work are applicable to us as well. Another aspect is that we didn't want to take venture capital funding for this because it has consequences that I'm going to get into shortly. But around the same time, Meteor took $2 million US dollars in funding. A project called Parse came on the scene. And today, Firebase is everything we wanted Hoodie to be, except we have proper offline support, even though they claim it. And you could have run, or you can run Hoodie yourself or have it run by someone you trust instead of Google. Quick aside, the funding cycle is usually like this. You get some funding, you hack on something cool for a couple of years, probably 2 years usually, then you sell out and go work for Facebook. That is exactly what happened to Parse, and I had made that story, like that slide is from before Parse got sold and shut down by Facebook. Sorry, open sourced by Facebook. When building Hoodie, however, the Node community and the JavaScript community at large came to the idea of having small packages, loved about like splitting up everything into smaller packages, and NPM was the living embodiment of this, and we were big fans, so we went in wholeheartedly, and we had some really nice results, mainly contribution ergonomics. If you want to fix a bug in a software project, if there's a tiny module that you have to fix, that's easier than having a big project and finding where the actual code is that you need to be doing. To the detriment of contributor ergonomics. When you have all these little packages, and when there's a bug fix to one of those, you have to make a new release, then make an update of the dependency of the release that's of the module that is ahead of it in the dependency tree, and go all the way up. Within a week, we were fed up being maintainers. So we did what self-respecting people do. We automated ourselves away. We wrote 2 tools. One is called Semantic Release, which I know some of you are using here, and Greenkeeper, which I also know some of people using here, which is very nice, which with semantic release, all you do is merge the contribution request, and then a new release happens, and then Greenkeeper will give you another PR on the subsequent dependencies. You just merge those, and eventually you have a major version release. We were back to happily hacking on our open source project. Greenkeeper in itself was one of the first source augmenting robots out there, which really pioneered this whole model of today it's GitHub Actions and do all the things that you want. But here we are. 2 years into Greenkeeper's lifecycle, people started doing something called monorepos, where have multiple packages in a single source code repository. And we really thought that was going to be a fad, and people would eventually see the light of doing single, separate packages, because, well, we put in the tooling, and people liked this, right? No, people were used to doing things that way, so they kept doing this, and then Lehnardt came around, and it was here to stay. So we had to rewrite all our architecture to support this because it wasn't really meant to be this way. But we got there eventually. But at the same time, around that time, one of our users said, well, I really need to manage multiple package JSONs for dependency updates. And we said, yeah, maybe later, we don't care. A couple months later, well, if you need this, use my project Renovate, which is now one of our esteemed competitors. So we took too long, didn't get off our asses here. We took another year to ship monorepo support, so they basically took all our monorepo users until we shipped it, which is a lesson learned, I guess. And earlier this year, GitHub shipped dependency updates natively on the platform, which with all the stuff that we have pioneered, which is very, very nice to see that these ideas spread really wide. So what can we learn from all this? Let me breathe for a second here. What seems obvious to you will not likely be obvious to others. HTTP and JSON look very obvious today, unless you're a GraphQL person, but that only builds on top of that rather than is a different idea. At the time, binary and XML was a loud voice in the community. Logicless versus logic-full templating, not quite easy to understand what not easy to know which one was the one that was going to stick. Turns out it was a little bit of both. And then the small module versus monorepos, we really thought that was going to be the one thing, but it turned out to be a little bit more complex. But just because people disagree with you, that doesn't mean that you're right. Right? That's a very important lesson, especially for all the white cis men here. It's really tough to filter out what is good criticism, what is a good point here, and what is noise in terms of this is a distraction. One of the things that you can do is stay on top of things. So once you start seeing, it's easier for open source projects and products. Once you start seeing competing implementations, that's a very important signal, because you know you're onto something. Like if you're copying you and improving on you, that's a good thing, right? And then if those things gain traction by having different ideas, steal those ideas. Like be ruthless, go after them, have them. Like MongoDB came up after CouchDB, fueled by $2.5 billion US funding to get you all that marketing swag. Hogan and Handlebars, Meteor, Parse, and Firebase, all of these things have ideas that build upon stuff that we pioneered at Hoodie and Couch and Mustache and everything. So it's very important, on the one hand, to hold on your design principles. Like logicless templates are logicless. The functions in Couch have to be pure. HTTP and JSON is the right call, right? But hold on to them like you hold on to your opinions, I hope. Reevaluate them in the face of new evidence. Right? See if like the short regex-based parser in Mustache was probably like one of the proudest things I've done, but it also had to go, but I didn't let go soon enough. So listen. Your community and your customers will tell you what they want. And while it's your job to design the car, when they ask for the faster horse-drawn carriage, you also need to realize when it is your job to just put a spoiler on that horse-drawn carriage. Like sometimes you don't have to be clever. Sometimes you don't have to invent the car. Say no a lot. Try not to get distracted by some squirrel, regardless of how shiny it is. In hindsight, if I can talk to my 10-year-ago self, I would say, like, fuck CouchApps. Let's not go there, and let's not try to convince the world that you have a new infrastructure. Focus on the database bits. If they are good enough, more people will come, and maybe the other stuff is going to happen. Unless that idea doesn't let go, and I'm convinced of this, the core of this idea to this day is why we're still working on Hoodie. But then maybe make it a separate project so you don't confuse users of your base project that we're doing here. And then getting towards the end here, it's impossibly hard to change how people work and think. When we got into CouchDB and evangelized and said, hey, use CouchDB, schema-less storage, you don't have to worry about an ORM. People are like, no, I like the ORM. It gives me schema definition, schema validation, schema migrations, all of things that you can do with CouchDB. The only pitch we had was, you can do these things later. You don't have to do them up front. You can experiment first and make them solid later, because you need all these things if you want to do proper longevity, longly lived project that you want to do. And developers will hold on to the knowledge they have and the way they know they can do their job with their life. They are viscerally afraid if we want to take away their livelihood. It's extremely hard to change them from under them. So every tech stack that you propose newly that should replace something old will have to solve the same problems at some point. It may have to solve them differently, but you can't, like, it will have to make people who come along more comfortable. Oh, sorry, going the wrong way, sorry, this way. And then finally, nascent ideas will pop up in many places. Like, we weren't the first JavaScript conference that year. We weren't the only mustache-y logicless template. This year we weren't the only document database around the times. Like, many ideas come around, and sometimes it's really hard when they actually do. And this is maybe the hardest truth here. You only know that an idea stick after it has stuck. Like, that's tough, right? One of the ideas for this talk was like to give you the clue to this. The clue is that's true for everyone. Nobody has a leg up. So keep at it. Someday your idea might make it big. Listen to the people who give you criticism, but also don't listen too hard to them. Keep avoiding venture capital. I would recommend this strongly to this day on. And don't work for Facebook. Thank you very much.